after an exceedingly long wait for it to save. So, how do I solve for A, B, and C? I times by the common denominator, which is what denominator? The one on the left side, always. Is this going to be ugly? Not that ugly. So the common denominator is 4x plus 1 and 2x minus 3 quantity squared, which means the left-hand side always just cancels down. So being left with 19x minus 32, that's not bad.
What does that be?
Okay, what's going to be left here when I take it times the first fraction? Yeah, the a and the 2x minus 3, quantity squared. Okay, we'll deal with that issue in a second. On the b, well, because I'm going to cancel the 2x minus 3 quantity squared, so I'll have the 4x plus 1. But the c one is going to be extra fun. Yeah. You'll still have one of the 2x minus 3's, and you have a 4x plus 1 left. But we all love to FOIL. Sound confident in that statement. Okay. Anybody can watch this. Oh, what joy. Although I do get occasionally a strange comment or two back from some video. One time it was, your video was really rad. How do I say that? Okay. So, can we all FOIL this and distribute A at the same time? Because that's quantity squared. So that's going to be 4a x squared minus 12ax, thank you, plus 9a. B's not bad, 4bx plus b. And then the c we also need to FOIL and try to distribute if we can. 4 times 2 would be 8cx squared. Yeah, do your outers and your inners. That's a positive 2x and a negative 12. Should be a minus 10 in the middle, 10cx. And then the last will be minus 3c. Well, our equations here to solve for A, B, and C are going to have a few more terms in them. Squares on the left-hand side. So yeah, 0x squared equals 4a plus 8c. Is that our only squares out there? Looks like it. So then 19, if I go find all our x's. Negative 12a, positive 4b, negative 10c. Well, I wrote it, it just didn't want to come along with it for us. And then lastly, we have negative 32 equals all our constants, which we have a 9a, a b, and a minus 3c. So now, this is an algebra 2 question. How do you solve for A, B, and C? Yeah, you got to pick two and eliminate. But the top one only has A and C in it already. So put the other two together and eliminate the B's. That way you'll get another equation that has A's and C's. Your goal is to get two equations that have the same two variables in them. Then you can put those two together to eliminate down. So, okay, we're taking the bottom one times negative 4, I'm hearing. I'm kind of out of space here. So if I take that times negative 4, I'm leaving the 19 equals alone. And I got to take the bottom one times negative 4, which would make a positive 128 equals negative 36a, negative 4b, and positive 12c. And you're looking at those numbers going, really, 128 plus 19? That's not a real optimistic number. My b's are going to cancel, so it's going to be a negative 48a and plus 2c. Well, we like plus 2c. Yeah. Okay, if not, sometimes I knock the plug loose, so I need to check the plug. Look at the back of the unit. Let me pause just a second. On the back of the unit, is the plug going from one of them to the other?
You were still recording.
I was? Oh, boogers. Did you guys pause it?
No, it's there.
Oh, it's still going. Oh. Sorry, calculator issues, meant to pause you. Hope you fast forwarded. Alright, so now where? Why did we do that?
So now we can put the, or no, we can, you put that one to the other one.
So now I'm going to take the 4a plus 8c can go over that with that one. In fact, I'm going to 0 equals 4a plus 8c. What would you like to eliminate, the a's or the c's? Okay, and this is good news because you're looking at it going, this is a pretty easy elimination. Hopefully I haven't messed something up. So I'm taking the top one times.
Can you take the bottom one times a quarter?
You want to do the bottom one? I don't care. Okay, fine. You all want to do the bottom one. Seriously? You're right. I am. I'll erase it. Whoa. We got the flash. Now we get to say. Okay, that was better. Alright, so you were taking the bottom one times 12?
Quarter.
We're trying to get rid of 48? Oh, you're dividing the bottom one by 4. Oh, wow. Ooh, aren't we sophisticated? You know, that's the first time I think anybody's ever told me to eliminate with a fraction. But yes, it's legal. So I have 147 equals negative 48a plus 2c, and now you're saying we have 0 equals negative a minus 2c? And here's where we say our prayers, because I got a negative 49a, and we hope 49 divides in there nicely. And it does. It does. Negative 3. 49 times 3 is 147. Woo! Yeah! Well, that's A. Now what?
Oh my.
No, then it's just plug in. I would plug it in the 0 one and go, oh, so now 0 equals 4 times negative 3 plus 8c, so that's not going to be bad. Can I add that over and say that's 12 equals 8c? And, okay, we didn't get totally lucky. That's not going to come out to a whole number, but it's divisible by 4, so we're down to 3 halves. They will do fractions. Technically, you could do 1.5, but the book will do fractions. Now, plug it in to find B. The bottom one, the negative 32. Okay. So negative 32 equals 9 times negative 3, oh, plus a lonely little old b, minus 3 times 3 halves. Darn, I was hoping that would cancel down. Nice. So, if it was me, I would go, hey, look, 9 times negative 3 is negative 27. If I had that over to the other side, I'd be down to negative 5, and then I'd have b minus 9 halves. So I actually have to add 9 halves. You could have added it all up together. You all use your calculators to do so, but it actually comes out really quite nice. If I'm 5 would be 10 halves. So negative 10 halves plus 9 halves is negative 1 half. That's tolerable. They aren't, now, if you are not going to come out with something like 37/359 or something horrible. If you do get fractions, they'll be reasonably simple. Yep, we still have to integrate it. Woo! Yeah, look excited. Okay, y'all are gonna help me now. So the 4x plus 1 had a, and a ended up being, I'm gonna, a is -3. B was, see, my sheet is wrong, so I need help. B was which one? Half? -1/2. And C was the 3/2. Okay, so we've now written them in our original fraction. Seriously, most of the time, because now you're now down to the easy part. This is usually better. So I know I'm going. Yes. Time? No, not time. Oops, B was squared, not C. Yikes, sorry. Okay, B squared, not C. That would be big. Okay. So what do you think I'm going to do on this first one? You're going to use sub it. But one little tiny thing am I going to have to watch out for here? Because you really could shortcut it. You should be seeing a natural log coming at you. Yeah, if you sub the bottom, 4x plus 1, you're going to get du is 4 dx. So you're going to end up with a du over 4 in it. You're going to pull the -3 out front and have a 1 over u. So you actually really have what out front? Yeah, you really have a -3/4 natural log of the absolute value of u. So we might as well go ahead and integrate. Oh, you want to, yes, you could go ahead and switch it back to the 4x plus 1, since we're having so much fun with it. Okay, second one, is it going to become a natural log? It's got a square. It's not. So we probably better think u substitution on that one as well. And once again, you'll soon start to see patterns in these. That du is just going to give us a 2, so that's no big deal. I'm pulling the -1/2 out front. That's going to give me 1 over u squared and a du over 2. So yep, it's going to be a 1/4, but you actually have to integrate. 1 over u squared isn't going to be natural log. Yeah. Yes, but why? I want to. Yeah. You're going to have to bring that up as u to the -2. That one can actually integrate like normal power rule integration. Add 1 to the power, divide by the power. So it's actually going to be a -1/4 times, I'm going to do this in steps so I don't lose anybody, use -1 over -1. So in reality, that's a positive 1/4. And u needs to go back to the bottom. So it's really 1 over 4 times the quantity 2x minus 3. Boy, howdy, that was a nice one. I'm just copying this other one down so they're all on the same level. And last but not least, this third one is short and sweet. Are we getting to the point where we can see where it's going to go without having to use sub the whole thing? 3/2 is going to go up front. That's going to end up being 1 over u. What's dx going to be? Yeah. Dx is going to be du over 2. So I'm really going to end up with 3/4. Integrating 1 over u is going to be enough. Natural log of 2x minus 3. Now, is there anything we can combine? Two of them are natural logs. The middle one is not. But the two that are natural logs, I'm going to reverse order here. I'm taking the third one and writing up front. Time. Ah, buggers. God, I want to be done with this.